Hey everyone, I just want to go through the warm-up to remind you of what you learned about last class. And so we're going to go through those answers, and then I'm going to give you a quick mini lesson on what you were doing this class, which is distance day 2. Okay, so here we go. Let me get a pen up and running. Perfect. So if you needed to find the distance, remember that last class we talked about drawing out the vertical and the horizontal distance to go from point A to point B. So you wanted to make like a right triangle, right? Like a 90-degree triangle. And then you want to count the over. So I see 1, 2, 3 on this side, and you want to count up 1, 2, 3, 4, 5 on this side right here. Right? And the side that you're looking for, the distance, is always your C side whenever you're using A squared plus B squared equals C squared. Okay, so when we're using this formula, it doesn't matter which one's a 3 or which one's a 5. I could do this like 3 squared plus 5 squared equals C squared, or I could do this 5 squared plus 3 squared equals C squared. It doesn't matter which one because I'm going to get the same exact thing. Okay, so 3 squared is 9, 5 squared is 25, right? And then when I add these together, I happen to get 38, if I'm not mistaken, 26, right? So 9 plus 25. I'm going to add those two numbers together. I get 34. What was I thinking? It's been a day. And this was one of our examples from last class. And then, because you want to get rid of the squared, you have to do the opposite of squared, which is the square root on both sides. So you get that the square root of 34 is equal to C. And now you could get that as a decimal if you wanted to, or you could leave it as that in case you did want to get it as a decimal. That would be like 5.83 would be what C is equal to. Okay, so we're going to take this idea of a distance, and we're actually going to apply it to finding perimeters of shapes on the coordinate plane. This is something, so problems like this are things that come up on the SAT, on the ACT, on these really important tests that you might be taking for either high school graduation or because you want to go to college. Okay, so let's take a look at this problem. Jamie needs to build a fence around his garden. That fence is illustrated by the polygon A, B, C, D, E, F in the coordinate grid below. Each unit represents 1 yard. Okay, what is the total length? Okay, so I see the word length of Jamie's fence in yards. So this shape that we have before us, so from A to B to C to D, all of these all the way around, right? That's what this says, around, is the fence. Another word for all the way around is the perimeter. Let's see if I could write this here. Perimeter. It's supposed to be an E. I'm sorry. So this is the perimeter all the way around. Now it says we want the total length. Another word for length is distance, like your distance formula. So what that's telling us is if we want the perimeter, we want all the way around, we want to find the distance. Now, some of these sides are really easy for us to see because we can just count it. So side AB, okay, take a look at side AB. I can count from A to B. I got 1, 2, 3, 4, 5. So this is 5, right? I can also count another side. Give me 2 more sides that I can count. I can also count from A to F. So from A to F, I can count 3. And I can also count from E to D, which also is 3. So these are the ones that I can count. There are others that I cannot count. So anything that's like a diagonal, I cannot count. So for each one of those, I want to draw my triangle like I did on the previous example, right, which was the do now. I want to draw a triangle on the sides to figure out what the distance is. So let's do BC. Okay, let's take a look at BC. So to do B to C, I'm going to draw my triangle. Okay, and it looks like this triangle is side 4, and this side right here is 3. And then I'm going to use a different color. I want to do the same from C to D. So I'm going to draw my triangle from C to D. So I'm going to use a different colors. Hopefully you can see that. C to D, it looks like I'm going 1, 2, 3. Oh, this is also 4, and this is 3. So what do you notice about this? What do you think this is telling me? If this triangle here, the one in red, has a side of 4, a side of 3, and I'm looking for the third side, and this triangle in green has a side of 4 and a side of 3, and I'm looking for the third side. So what do you think that is telling us? Well, it's telling us that both of these sides, so BC and CD, are congruent to each other. So whatever I find for one of the sides, the other side's going to equal the same. Let's check out side FE. Okay, so I'm going to check out side FE, and I'm going to see if side FE also gives me the same type of situation. Okay, so I'm going to draw my triangle from F to E. Okay, and it looks like F to E is also 1, 2, 3, 4, and also 3. And so, oh, I'm noticing that means that this side right here is also going to be equal to each other. So because I did this first, I don't need to do the Pythagorean theorem 3 different times. I only have to do it one time. Remember that the diagonal side is always C. So I'm going to use the Pythagorean theorem, the a squared plus b squared equals c squared, right? And it doesn't matter which one is a or which one is b. Oops, just erase that. That was supposed to be squared. 4 squared plus 3 squared equals c squared, right? 4 squared is 16. 3 squared is 9. Add those two together, I get 25 is equal to c squared. Because I want to cancel out the squared, right? Because I want to cancel out this squared right here, I'm going to square root both sides. And the square root of 25 is actually a perfect square. The square root of 25 is actually 5, right? Which is fantastic. So what that means, okay, what that means, my shape kind of looks like this. Oh my God, please don't laugh at my drawing. It's like horrendous. It looks like that. It's so horrible. Okay, but what I'm trying to draw this shape right here. I'm trying to show you what we know. We know one side is 3, we know the other side is 5, and then we learn that each diagonal side is also equal to 5. And that flat side on the bottom is 3. So if I now need to find the perimeter, right, the perimeter means add all sides. So I'm going to add each one of these sides right here. So let me just add in, I'm going to kind of duplicate this. Let's see. Duplicate so that I can make some edits. Perfect. I'm just going to erase a few things. Okay, so I did the Pythagorean theorem, and now I want to find the perimeter, so I'm just trying to make some room for myself here. I clearly did not think this one through. I did not think that my writing was going to be so big. So to find the perimeter, which I'm going to delineate as P, P is 3 plus 5 plus 5 plus 5 plus 3 plus 5. Okay, so I'm adding all of the sides. And then that should give me my perimeter. So 5 plus 5 plus 5 plus 5 is 20, and 3 plus 3 is 6. So the perimeter actually comes out to 26, and it says each unit is 1 yard. So this is 26 yards is the perimeter, and so the fence is 26 total yards. okay? So that is essentially how you would find the perimeter of a shape that is not necessarily flat all the way around. Okay, so I'm going to take a quick pause right here.